What's nice about this problem is this. Do you notice something about these two areas? They're the same. They're symmetric, right? So that if I find the area of the top one and then multiply it by 2, won't I get the same area? Wouldn't that make my life a lot easier? Because this is just y equals x squared. This guy down here is y equals minus x squared. So I just essentially look at y equals 0. So it's x squared and 0. Upper curve is x squared, lower curve is 0, and then double it. So this is the integral from 0 to 1 is what they told me. Thank you very much. Phew. Yes? So the integral from 0 to 1 of x squared dx, and then double it. That gives you the area of the whole thing.
So we go from 0 now, from -1.
-4?
No, -1.
It's always going to go from 0 to 1 because it's bounded by, it's on the x values. So this is x equals 0. This is the line x equal 1. Because they told me that it's the line x equal 1. All right. The other way to go with this is the integral from 0 to 1. The x's are still the same. It's the y's that are going to change. The upper curve is x squared. The lower curve is minus x squared dx. And notice what you end up with. The integral from 0 to 1 of 2x squared dx. You're doubling x squared. So you end up in the same place. But you can use symmetry in your favor. Now this is the one that's exciting, and I'm glad that I printed this out in Technicolor so you can see how many lines do I have. How many graphs? 3, right? I've got a straight line, and it's bounded by the curve 1 over x squared. That's this guy. The line y equals x, and that has to be this one because 0, 0, 1, 1. And the line y equals x divided by 8. Now, what's so bad about this? This makes this a problem which is a little bit more difficult. Now, think about drawing rectangles. What happens? Upper minus lower, upper minus lower, upper minus lower, upper minus lower. What happens? Do you always have the same upper curve? No. As a matter of fact, they switch right here. Here the upper curve is x. The lower curve is always the same. Here the upper curve is 1 over x squared. So I've got two integrals. And it breaks up at that intersection, which fortunately is x equal 1.
So we're just trying to do 2.
You have to do two integrals, yeah? First integral goes from 0 to 1, where the upper curve is that green one, x, and the lower curve is x over 8. Then you're going to add to it the second one, which goes from 1 to 2, where the upper curve now is 1 over x squared, and the lower curve is x over 8. You have to take it separately because the two curves change. And that's why whenever I'm doing problems like this, if I got more than one involved, who's the upper, who's the lower? And if any point that they change, I have to then mark that as a point where I've got to start a new integral. If either the upper or the lower changes. And then you can find the answer to that if you like. I think I may have it worked out on my notes online. I usually do.